Hi. Today I'm going to talk about a new programming language that has been under development for the last 5 years or so. At a not super fast pace, but picking up more recently, which is a language called Rhombus, or at least that's the current name, which is an experiment in building a new programming language on the Racket platform that tries to address a bunch of the limitations, inconsistencies, historical accidents involved in Racket, which Racket is now almost 30 years old, and Scheme, which it descends from pretty directly, is significantly older than that. So amazingly, the pre-Racket history of Scheme is now substantially shorter than Racket's history since it was created. And tries to address a bunch of those things by creating a new language that can do things in various nicer ways. Maybe the most interesting thing about Rhombus, though, is that one of those things that it tries to address is all of the parentheses. And so Rhombus is an attempt to, among other things, have all of the good stuff that you love from Lisp, Scheme, Racket in a notation that looks like this. If you've ever wondered how it was that you were going to explain to someone that you should write addition this way, Rhombus is there for you. So that's the big thing that that's one of the big things that Rhombus does differently, and it's the part that's most novel, I think. But like I said, Rhombus has a lot of other language features and has a different spin on a bunch of existing Racket language features, and tries to do a variety of things differently in, I think, interesting ways as well. So that's the idea. And as you can see, one of the nice things about Racket is that it's built around this hashline concept, and the language can change just about everything. So you have a REPL that works for a totally different syntax, and you get syntax highlighting for a totally different syntax. How many of you could tell, without me explaining it, that these were comments? Everybody, great. So that's, I think, one of the justifications for picking a syntax that I don't explain when I start talking.
Except you did.
What do you mean?
Well, so far the whole start of your talk has been about the syntax.
Right, but I haven't explained what
Yes.
the rules of the syntax
Yes.
are. I've just written them on the screen, and you've known what they do. And that's the idea. Talking about the syntax, sure, we're going to do a lot of that. But explaining the syntax, again, how many people guessed that this is what was going to be produced? Everybody, right? So that's the idea. Okay, so similarly, you've got your basic data structures. You've got this is immutable, nice data structures for maps. This, one of the new features of Rhombus is that this is not cons. This is a, if you know this, a relaxed radix balanced tree, which provides log time indexing, but also log time append and lots of other log time update in the middle. So lots of so some fancy data structures to similar to what you see in Clojure, where you get more efficient functional data structures just out of the box. So that's one fun feature that I'm not going to talk too much about. But because for the most part it's just transparent that when I write
So I guess this kind of brings up the question of sort of how much does Rhombus lean towards being a pure language versus an imperative language? And 'cause like
yeah, I think
the various schemes and rackets have sort of like wavered in different directions over the years.
It leans a little bit, a tiny bit more than Racket towards being pure, but only a tiny bit. So it's mostly just in the same place that Racket is. And the only way it is that Racket, as a descendant of Scheme, has a bunch of things that are mutable that maybe by default that maybe shouldn't be, and similarly weird. There's like you have to deal with mutable strings, and that just turns the string data type is by default mutable, and except literal strings are immutable, and so there's a bunch of like mutability and or vestiges of mutability in weird corners in Racket that like if you ask whether something's a string in Rhombus, it's an immutable. It corresponds to an immutable string in Racket, and if you want to deal with mutable strings, then you have to explicitly say that you want that. So it's making, if you think about the change that Racket made to make cons as immutable, rather than having like a cons data type that had a mutability flag, and then you have to worry. Racket conses are just immutable, and if you want mutable data structures, you know where to find them. Then it's more of that, but fundamentally it's in the same, like mutability is fine, but we favor immutability in the same landscape as Racket or OCaml or many other languages. It's even a little less favoring immutability than something like Clojure, where mutation is a little bit more segregated off. But that's what I would say. Yeah. So this operation is more efficient than it would have been in Racket, but you've got but that you can't see that log time append when I just type it out. So that's and you've got, of course, indexing. Yeah. So the usual things do the usual stuff, and yeah. So that's a few of the basic things. So that's the idea, and yeah, so it's of course these ideas, neither the ideas about macros nor the rest of the ideas are all totally new. It's really putting them together in an interesting fashion. fashion in a sort of holistic language design that produces something interesting. Okay, so let's see some more programs. So this is also the plan for what I'm going to talk about. I'm going to talk about, I'm going to demo some more. I mean, this whole talk is going to be demoing, but I'm going to just demo some programs, and then I'm going to talk a little bit about the syntax and how that works. I'm going to show off writing some macros, and then I'll talk some about static information, which is one of the interesting features of Rhombus. It's not macros. Or, of course, this being Racket, it's built entirely on the macro system, but it's not about macros and non-S expression languages. So here's everyone's favorite program. Yeah, so you can see how this works. So a few things here. One, again, function call works like you were taught in 6th grade. You write the name of the function and then some parentheses. And so one thing to see is that Rhombus has adopted a fairly conventional syntax, unlike, say, the ML and Haskell tradition. It's not, juxtaposition is not function application, unlike weird programming languages like Fortress. Juxtaposition is not multiplication. I mean, you can do things with juxtaposition, which we will see later, but fundamentally, it looks more like Python than like other functional languages that you might see. So that's one thing. Second thing is you can see that the syntax is a little bit white space sensitive here. That maybe there's no termination. There's no terminator for things. There's not. Actually, maybe you can't see the white space sensitivity in this example. But we can write. Program. Everybody knew that was the factorial element, right? So white space sensitivity. We've got we don't have statement separators or statement terminators, and this new line just opened up a block here that I can write a sequence in. And one thing that maybe what you didn't notice that happened is that Dr. Racket knows how to indent Rhombus. When I hit enter, it just went to the right place and indented correctly. And that's not built into Dr. Racket. That's now communicated via protocol from the language, the hash line. So that, and this has benefited Racket languages in general, so now you can get better indentation in Scribble and other
So this protocol was sort of a new thing that was developed as part of developing for Rhombus.
Yeah, previously the indentation support was baked in and fairly S expression specific. And there was a list of keywords that indented like define and indented like lambda, and now it doesn't take into account keywords, but it does use the lexer that is used for syntax coloring to also provide information about indentation.
So this is kind of in some kind of in the syntax highlighting part of the implementation, not like in the macros used to define Rhombus part of it. Or they're the same.
So like the idea is that Okay, so here's we've got some configuration in. This is the file that defines the hash line, and there's some configuration, in particular right here, that tells us about the indentation extension, like the default extension to save with, and how to. So here's another feature is there's a little menu up here in Racket that says you can see a list of definitions, but of course definitions in Rhombus look pretty different than definitions in Racket, so you can't just look for left paren DEF something. So there's configuration for that, and that's all in the information for the hash line. And there's a protocol, and there has been a protocol to do things like syntax highlighting for a long time, but and things like the default extension, but we've extended it more to do things like indentation and to make the REPL work better, things like that.
But then the binding occurrence information is coming from the expander still.
Yeah. Yes. You get information about binding or about syntax errors from expanding the program in the same way that you would in Racket. Okay, so
is I'm guessing that just the way Racket is kind of one of its goals is to be like a good teaching language. I assume that's also a goal of Rhombus.
So that hasn't been so there's a couple things to say there. So this has not been an initial goal of the design of Rhombus specifically, but just like Racket is designed to be a language in which you can build teaching languages, and that's sort of where it came from in the beginning. The plan is also that you can build teaching languages in Rhombus, and in fact, Matthew Flatt and Ben Greenman have built one already, so they've been teaching for a long time with a variant of Sriram Krishnamurthy's PLAI book. They have a typed version of the PLAI language called Plate, and they wrote a new, or Matthew and Ben created a new variant of that language built on Rhombus that uses the syntax and again typed unlike Rhombus. It's similar to the typed PLAI language in that it's a language that's similar to Racket. Plate is similar to Racket language, but it's typed in an ML sort of way, and has various ML-like constructs for teaching PL, and their new language called Splate is similar in that it built on the Rhombus syntax and built on Rhombus, but is focused on teaching this course.
For teaching what course?
This PL course.
Okay. So it's not like intro to programming.
Right. So I think building a beginning student variant in Rhombus is an interesting project that someone will do at some point, but no one's done that yet. But certainly you could do that, and Rhombus is designed to be the sort of language that you can build new languages in exactly the way that Racket lets you build beginning student in it. Okay. And I think one of Matthew's goals with that language was to teach PL without having to teach as much of Racket. That it's sort of a language that looks like you expect if you know some programming languages. And you still have to teach some functional programming and some pattern matching, but just a little less than you have to by Okay, so that's factorial. We love factorial. Okay, so let's look at some other versions of this program because we all love factorial. Okay, so here's a different version of factorial that shows a few other features of the language. So first, we've got some static information on this. We've got we've got an annotation on the parameter to factorial that says int. And what does that annotation mean? And then we've got pattern matching explicitly. So one new thing about Rhombus is that pattern matching is built in to the whole language very permissively. So as you saw, you can define in the same way that it's built in ML and Haskell. So we saw up here, we've got pattern definitions by cases with patterns, and there's also an explicit image form. So that's one thing. Another thing to see, we've got keywords, which use the OCaml syntax for keywords. Keywords are used for lots of things, like in Racket. In fact, for more things, like there's for else clauses and things like pattern matching. And yeah, so that's one thing. And then
what's the role of the tilde there?
That's just the syntax of.
I guess I'm not sure how to parse that.
So tilde is just the tilde, and then some name is just the syntax for a keyword. And so this is a literal keyword, and if you write match and you have a literal keyword else, then that's just an else. That's like writing underscore.
So I guess here you could have also written just the word else, which would be
yes,
yeah.
yes, I could have written that and so,
You knew that one in my head.
yeah, yeah. So things to work. So you can see one thing is we've got these annotations, and annotations are dynamically checked. You could say if I try to pass something that's not an int, I get an error. And again, in the theme of cleaning things up, this also doesn't satisfy even the traditional scheme predicate integer returns true for the number 5.0. And there are reasons why, if you think about the numeric tower in a certain way, that makes sense. But in reality, nobody wants this to match, and so it doesn't. So that's a useful. This is the sort of thing where the decision about integer home was made a very long time ago, and can't really be changed in Racket now, but we don't have to keep it. So we've got annotations. You can write annotations that don't check dynamically. And this is why you should turn off dynamic checking of your annotations. Anyone see why this program has an infinite loop?
Never matches 0.
Yeah, it never matches 0 because that's an exact 0, and we're not going to get that. Whereas if we run this program again,
Is it really an issue of being exact, or is it just that it's an int, not a float?
well, it's that matching of like we can.
Can we use a predicated there, like for instead of 0, just use like out the school match predicated for values.
Yeah, so that doesn't match 0 because 0.0 and 0 aren't the same. So pattern matching doesn't coerce between representations because you don't want that. Whereas if we did so you can turn off dynamic checking, but as we know here at Indiana University, maybe you don't want to.
Does the annotation do anything if you turn off?
Yeah, so
Or is
we'll
it just
the annotation provides static information even when it's not doing any dynamic checking, and we'll talk a little bit more about static information later. So that's okay. So that's and now let's look at one more simple example. Here's an example of the flexibility of the syntax, which is we can write new operators and even postfix operators to do things like make extremely convenient syntax for factorial, the thing that every functional programmer cares about.
And I'm guessing, so this, you can do mix fix, prefix,
mix fix is,
or infix.
you can certainly do infix, and you can do mix fix like the way like Hopper Active does is a little trickier, but you can do postfix, prefix.
It's not mix fix, but
I mean, if you work harder, you can certainly write mix fix, and we'll see some examples of that sort of thing later. But that takes more work than just writing an operator.
so then I can't resist asking what parser technology is being used here.
So there's, so I think the answer is mu to that question. That turns out not to be the right question, and that there's not parser technology in the sense that you're thinking about for this.
I mean, just like even the sense of there's an algorithm, right?
Yeah, so there's an algorithm called enforestation, which originally was in John Rafkin's PhD work about a language called Honu that was also, and then has been subsequently been applied in some other languages. But the short answer is that sequences of operators are sort of pre-parsed into just a list of operators and operands with no structure, and then the macro expander asks the operators to parse the sequence. And so fundamentally, the operators just are arbitrary functions that consume parts of the sequence, and then they return the rest of the sequence to be parsed, and then the process continues. So that's why it's not really like.
Well, no, I mean, this is what you're saying is helpful to kind of
but
understand.
Right. I think
like a different answer could have been like so. For example, Isabel, they use like something a bit like early.
Yeah.
Right.
But I think what I'm trying to say is that it's not like there's a bunch of parser technology that people have developed that is extensible and composable in various ways, oriented around context-free grammars and variants of that, and this is not like that at all.
Right.
There's a pre-parse into a sequence of tokens, an unstructured list of operators and operands, and then the operators themselves just consume portions of that sequence and parse it themselves.
So, actually, can you explain what this operator n being line means exactly? Like, how do I know that this is defined? Like, is n n isn't a pattern variable?
Yes, n is a pattern variable.
It is.
Yeah, that's why we just say match n.
Sure. Okay. I see. And I know that n is a pattern variable and bang is the thing I'm defining because, like, bang isn't allowed to be a pattern variable.
Yeah, and n isn't allowed to be an operator.
So there's certain sort of predefined notions of which symbols can be operators.
Yeah, we could make this a more fun operator.
Can vertical bar be an operator?
Yeah, so now we get the same answer. You can all tell that that's the same answer, right? Yeah, so operators can be more fun than that, but this is that's the syntax. And yeah, there's some rules which I won't go into about because I don't remember exactly what but they're similar to like Haskell has rules about what's legal as an operator, and can we let's letters there, and yeah, so that doesn't work. And this means something totally different, as you can see, that this is an infix operator. So there we go. That's the simplest extensibility that we've got in terms of the syntax. But yeah, the syntax is not super fancy, but is highly extensible. Okay, so that's our favorite demo program. Let's look at a little bit different demo program. So here's a implementation of a queue data structure. One thing to see is that Rhombus data structures are called classes, and they can have methods. And if you want to define a simple record data structure, you also call that a class, but just a couple fields. So I wanted to define posins. So there's the definition of a record, posins with 2 fields, so classes can scale all the way down to be as short as a struct definition in Racket, but they can also include classes, more conventional classes, and then you construct them like that, and you can get out the elements like that. So another big feature of Rhombus is dot notation that you'll be familiar with from a wide variety of other programming languages that you may have used. And this is a big win. Again, going back to teaching, I look forward to not explaining posin-x to students in the future. So that's posins.
Is list.cons the usual way now, or in Rhombus of saying cons, or is
so there's
just a little bit from Rhombus?
yeah. So if you want to write cons, you can write it in a variety of ways. Yeah, so we've got, so another thing that you get with, that Rhombus uses dot notation is you've got namespaces, and Rhombus uses this very pervasively. So there's, in the Rhombus language, you just have imported the list namespace, which means that the base namespace doesn't have as many things in it, so you're going to write things like list.empty and to create an empty list. And we'll get back to writing cons in a second. You've got, so here we've defined some fields, and here we've got, we can keep those dynamically checked or not, depending on our preference. So here we've got Q methods, we've got, and again, mutation, colon equals, someone should figure out a better font that like lines up the colon and the equals better. But that's a separate issue. So we've got add and remove, and call those the usual way with the. So we create a queue, we can define them, and then we can manipulate it in the usual way. And so, yeah.
Can you overload methods?
What do you mean by that?
Like, can you write the same method but with like one that takes 1 argument and one that takes 2 arguments?
Yes, because methods are just. So there's a variety of answers to this question, but the shortest one is just yes. I mean, for example, there's optional arguments, and so we can say v falls to true. And now we can do q.add.
Now, I suspect that you were kind of coming from maybe a Java mindset.
Yeah.
And so which is in Java does, type-based.
Yeah, there's no
overload
dispatch based on. So you can just write a method that's a function that takes whatever inputs it wants to take.
Sure.
And
The short answer is no.
I mean, it depends. It all like, can you overload methods in JavaScript or in?
No, I mean, so it's in dynamically typed languages, you don't have type-based overload.
Yeah, so there's no type-based overloading.
Right.
You can have methods that take multiple different numbers of arguments, certainly. The other thing you can do is that when I write q.add, this is fundamentally a macro application that is under the control of the binding of q. And so q could look at the number of inputs to add and do totally arbitrarily different things statically, including based on static information. Sort of in the same way that, like, I can write a function, something that looks like a function, f, in Racket, and when I call it with one argument that is a literal number, then it does one thing, and if I call it with two arguments that are literal strings, it expands into arbitrarily different code. And then I can come up with some way of passing static information, so I know some things are numbers, some things are strings, and do different stuff. So that's, and Rhombus builds in some pieces of that so that it's easier to do that yourself, but the class form does not have type-based overloading, and I think it would be a bad idea to write that kind of program. Okay. So, so here's the usual, and then, this is just, what you expect from writing classes, and so that's
I guess earlier when you introduced the square bracket stuff, I didn't realize that the type of that is literally capital LIST. Okay.
yeah. I mean, there's.
Is there also singly linked lists somewhere?
Yeah, it's currently called, now that we switched to what we're calling tree lists, that's called pair list. And we can do. So, I mean, this is going to not work anymore, but you get the idea.
With the plus plus, would you have to change the plus plus
No.
too? So that's like that's overloaded in some sense.
Yes.
base language is allowed to do overloading, but the users aren't. Is that what we learned here? That doesn't seem very fair.
You could write your own overlay.
Actually, I'm not. How does that work exactly? If I have like the paralist version of plus plus and the tree list version of plus plus.
I mean, we could look at the. So there's things that are appendable support. This is roughly a method of an interface. And,
Okay.
Okay. So things
Actually,
that
that's
are
cool.
appendable
Okay.
support the append operator.
Okay.
And you've got there's a bunch of.
And are the interfaces? Well, I guess there's no type stuff, type checking going on. But I guess I'm kind of like, do they lean towards like Java interfaces or traits or like maybe it doesn't matter because it's one type.
Yeah. I think the class system is a little less fancy at runtime than the Racket class system, but I think will it be more like Java or like Scala, I think is yet to be determined as we go forward with this.
Are lists classes as well? Like, can you use the dot method notation for them? But like, why do you?
So you can't.
Is it possible to pass something so in Java you would pass an interface to a definition. Like if you don't want to go through and change all the list to pair list, is there a way to pass a type to the Q class and say like I want to use list or I want to use pair list? Sort
So
of like a
can we
jam.
parameterize
Yes.
classes by the annotations? No, annotations are not. We don't have a method for parameterized annotations. I think maybe we will want that eventually. Again, there are senses in which this isn't totally fixed. I could certainly write a macro that that takes the name of a space that also needs to be an annotation, and that expands to this code. That's a way of doing parameterized annotations, but that's not quite the same thing that you have, but that's sort of how I would do it. But of course, those are going to have different names, and there's ways in which that's less nice than parameterized types. There's ways in which it's, of course, more flexible because you can abstract over absolutely anything. So that's. But I think the other thing to say is that the meaning of this is too flexible for it to be obvious how to do parameterization here, because this is really call an arbitrary macro here. And like const just happens to be just a function, but this notation does not restrict itself to functions. This can do arbitrary expansion type stuff. So fundamentally the only way to parameterize is by parameterizing in an expansion time way. and okay, so that's some fun with a simple data structure. Okay, now I want to talk a little bit about the syntax. Okay, so the syntax is based on the following idea, which is that the key to macro extensibility of syntax is an intermediate data structure that you can construct based on the characters typed in, and that then you can use expansion to go from that incrementally to a fully parsed AST. And in Lisp-derived languages, that is the S that intermediate data structure is the S expression, and it's a very sparse data structure, in the sense that there's very little structure in it. Arbitrary pairs and atoms, and so that's and you can write macros that add more structure there, but there's no more structure built in at all. And the basic idea of Rhombus is that we're going to do the same thing, but we're going to have two changes. The first is we're going to add the concrete syntax that parses into this intermediate tree data structure is not going to be written with parentheses. And that's an idea with a very long history in the Lisp and Scheme communities, in terms of a variety of syntaxes, sweet S expressions, etc. And then the second idea is that we're going to parse into something with more structure. And that data structure with more structure is called shrubberies, because it's like a tree but less bushier. So if we take something here, let's just take this and paste it in here. Hashline shrubbery just prints out the data structure that you get by reading the, and reading I mean to specifically use the name read, like if you think about the read function, it produces S expressions from arbitrary text. This is the same read, except it produces this more structured data. And we've got, you can see some of the structure here. We've got a group, which is just this line, and then this group contains 4 things in it: def and an operator. So we can tell a priori what operators are, where the operators are, and the number one. And
So you said group was a line?
roughly.
Okay. So is it, should I think of this as maybe like a slightly souped up just list of tokens? It's like a list of tokens with a little bit extra?
And individual group is going to, it's going to be this is a tree structure. So as we get...
Right, but it's not going to have a lot of, like the nodes in the tree, like I guess I'm just wondering how much...
So let's look at this.
Right.
So we've got a group, which is this whole thing turns into a group, and then the group is def and n, and then a block. And a block is the other important concept here in shrubberies.
So it knows about indenting.
Yeah, indentation is built in, and grouping is built in. And so things like parentheses are also built in.
It knows about indenting, knows about lines, it knows about parentheses.
Knows what things are operators.
And the colon is somehow just signifying the start. Like
Yeah.
colon and line is.
Yeah. And and the new line's not necessary, but we've got one group there, and so this is a very So those are so the idea is one, we've got read into this tree structure, and this tree structure happens to be represented as an S expression with symbol as the cars, but you should think of it as a sum of products, a recursive sum type, where we've got top and group and block as the various, and up as the various things that can go in various places. And of course it's very flexible. You can have a group that's just an operator. We can have more depths, more blocks inside. So it nests, and
Is the colon the thing that sort of says, oh, you're doing a new block here?
yeah, and there's ways that you can there's a few more details of the syntax. So we can put, let's do that. So here's another thing. We've got if you want to have group these things together, then you've got so you can see that this whole thing is now together because these vertical bars caused it to these parts to associate up to this, and those go together in Wonks. But yeah, so we've got some loose tree structure. So like I said, read into a tree structure. That tree structure has more structure than S expressions, and that that tree structure does not have anything like precedence for operators or so if we write let's write something here like you can see that the usual, this is just entirely flat. There's no a priori built-in sense that these parens go with this F, or that these go together and dot these. It's just, you've got an F and then some parens and then a dot and then a G and then parens and then a dot and then an H and then more parens. So the operators and their structure are entirely done later and as part of macro expansion. So that's the basic idea of shrubberies, and this is what enables macros for non-S languages without S expressions. Although maybe you could think about it as bringing S expressions to syntaxes that don't have a lot of parentheses built in them. But it would be, I think the the key idea is this richer structure, which lets you get something that works more nicely than the various non-S expression scheme syntaxes that lots of people and then the inforestation protocol that works for making operators work nicely. Okay, so that's we're almost out of time here. Is that right, Tenu?
Yeah.
So I will show one more fun demo. So here's an interpreter. This shows off a bunch of fun features. And so first we've got, again, pervasive pattern matching. But if you think about programming in Racket or in Scheme, in many cases, there's really two forms of pattern matching that you're going to use a lot. One is match for just pattern matching on things like lists and structs and data like that. And the other is the pattern matching that's built into the various macro facilities, syntax rules, syntax parse. And those two have inspired lots of things in each other. Pattern matching has certain similarities, but in Scheme and Racket traditionally, they're just different systems with different syntaxes and different features in different places. And the one of the things that Rhombus does is it unifies those entirely. So this is just match, and it's matching on a syntax object. And the single quotes are the concrete syntax for syntax objects, and you can pattern match on them, and $ is unquote. So we've got ... repetition as well.
In syntax, is it sort of, at the moment here, is it sort of fixed to Rhombus syntax? Is that the way I should read that, or? Can I be writing an interpreter for some other language here, or is it? Is it really interpreting Rhombus syntax?
It's just interpreting syntax objects, no binding, no. These syntax objects are going to. The pattern matching is designed to work well with shrubberies, but there's no commitment even to that, and certainly no commitment to the full details of Rhombus. So this is in the same way that you can use syntax case to pattern match on syntax objects of whatever form you want. You can do the same thing here. So. So here we've got a pattern that says we've got a syntax object that starts with fun and then has a parenthesis and then has a bunch of things that match identifier. And here we see another interesting aspect of annotations, which is annotations, when you write them in patterns, constrain pattern matching. This not only tells us later that it's going to be an identifier, but it constrains it to only match with our identifiers. We've got ... and then we're binding E, and then this is the usual pattern matching, except that we can use the pattern matching, the repetition syntax, the way we do in macros in Racket or Scheme, to construct data in the
this is a run?
Yeah, so this
a
is
runtime?
converting a function into a function which takes a rest argument and arbitrarily many arguments, arg. And then it interprets E, just whatever was here, with the environment appended to a mapping that maps the name that you got out of that identifier by unwrapping the syntax content associated with the argument. And we're just zipping those together, and you'll get the same error that you would expect from scheme macros when those dot dot dots don't end up lining up. And similarly, when you do a function call, we're going to interpret the function. It's going to produce an actual Rhombus function, and then we're going to interpret all the arguments in the environment, but we're just dot dot dot. So this is apply. You would have to write apply and map, but that just all happens in the dot 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 repetition. And then
If this little language that I'm writing the interpreter for, can I change the sentence? So like if I wanted functions to be fn instead of fun, can I just do that there?
Where did I write this? But yes, you can certainly do that.
It's found in the beginning. Let's go down. Not
Oh,
far.
yes. Yeah, no, we can. Yeah, so this is just the underlying shrubbery syntax. The same way, if you wrote something like this in Racket with S expressions, like there wouldn't be any commitment to using the name lambda just because you're writing a metacircular style interpreter. So then,
Wow, so it's like this is sort of really, in some sense, sort of taking S expressions and juicing them up quite a bit.
yes. So then you've got what you expect for interpreting parentheses. Note that, unlike in scheme, parentheses are meaningless. They're just grouping, but that also means we have to. There's a case in the grammar for parentheses, which is just interpreting integers. You just get the literal value of the integer. Lists turn into lists. If you have some stuff with an operator in the middle, then you look up the operator in the environment and call it on the arguments. So that's, and then here, so here's a little example of a program that calls some functions. And we've got a map, which is the environment, and look for unwrap off. This gives you unwrap op on the syntax object gives you the symbol for the syntax object, and then we just map it to a function that does plus. And you get the end. So that's a simple little interpreter, and it shows off the pervasive pattern matching. It shows off unifying syntax pattern matching. Shows off using ... for repetition, which can make a bunch of things nice, and you don't have to use this syntax of Rhombus. This is just this just uses the shrubbery parser, and then
Yeah, so earlier you made a remark like the syntax, like you're not somehow restricted to shrubberies in the macro, but it seems like you kind of are. I mean, it doesn't have to resemble the rhombus like names of anything.
Well, so you can, if you want to use quotation to construct syntax objects, then the thing inside the quote has to parse with the shrubbery parser.
Right.
But just like with Racket syntax objects, you can create them with cons and datum to syntax,
Okay.
and the same is true here. There's no, you could write some arbitrary function from UTF-8 characters
Right.
to syntax objects that does whatever you want, and that's not going to provide convenient pattern matching if it doesn't look, if your concrete syntax is actually S expressions, then the patterns are not going to look like the concrete syntax, and the quote is not going to look like the concrete syntax. But like that's sort of fun. You can't. You could imagine making quote extensible in a different sort of way, but that's a different the way that like Haskell splices. Haskell has ways of parsing sort of arbitrary strings that go inside particular brackets. But that's a different kind of extensibility.
You should call this a meta-rectangular interpreter.
Okay, I think on that note, we should call it. Thanks.
Really, really neat. Yeah, super fun to hear.